Section 7.8, partitioning a segment. So we're going to find the point on a directed line segment between two given points that partitions a segment into a given ratio. So really quickly, let's say we're going to have a segment AB. So it's a directed line segment A to B, and we want to put it in the ratio of 3 to 2. So that means we're going to break the line segment into a total of 5 parts. So I'm going to roughly do that. Those should be 5 even parts. They're not. But let's say they're even parts, so that means this is the point I'm looking for. 3 parts are on the side of the A, and 2 parts are on the side of the B. So that's a ratio of 3 to 2. So we're going to do that by using this formula. So A, or the first point, is going to be x1 and y1. B, the second point, is x2 and y2. And I'm going to use C to D is our ratio. So what we're going to do, and you're going to want to write this down, you're going to take the second number in the ratio, the D, okay, multiplied times the first x. So it's a crisscross. Plus C, the first number in the ratio, times the second x. And then you're going to divide that by the total, C plus D, the total number of parts. And then you do the same thing for the y. Calculate that out, and that will give you your point on the segment that would break it into that ratio. So I'm going to graph this and do this one. A is at -6, 5, so there's my A point. And B is at 4, -7, which is my B point. And my ratio is 3 to 2. So I'm going to calculate that out. So I'm going to take this to find the x value. I'm going to take the second number in the ratio times my first x plus the first number in the ratio times my second x, and that divided by 5, because that's what that total is. It won't always be 5. So to calculate that out, the x is going to be -12 plus 12 over 5, which gives us 0. Then for the y, we'll do the exact same thing for the y, except using the y values. So we're going to take 2 times 5 plus 3 times the -7, all divided by the 3 plus 2, or the 5 again. So that's 10 plus a -21 over 5. So the y value is going to be a -11 over 5, which is then a -2.2 as a decimal value. So the point we're looking for is 0, -2.2. So now let's draw that out and see if that does the division about like we thought it would. There's my second point. 0, 2.2 is about right there. Looks to pretty closely have divided into a ratio of 3 to 2. That's not always going to be your ratio, of course. That number will change. Now, we will also do examples where you're directed from B to A. So in this case, our ratio goes from B to A. So B is now our first point. So what I'm going to do is I'm just going to rewrite those numbers in the right order. So -2.5 is my first point. 8.3 is now my second point. My ratio is still 1 to 3. So let's go to a different color here. So my x is going to be found by taking 3 times the -2 plus 1 times 8 divided by, in this case, 4, because that's 1 plus 3. My y value is going to be found by taking 3 times the 5 plus the 1 times the 3, all divided by 4. So that's -6 plus 8 over 4, which would be 2 over 4, or 1/2. This is 15 plus 3, which is 18 over 4. So my point I'm looking for here becomes 1, let me write it down here, 1/2 is my x value, and my y value is 4.5. So that would be the point that would divide that segment into a ratio of 1 to 3.